Okay, welcome to day two of the Cyber Senate Rail Cybersecurity USA show. Welcome to all of our speakers and our attendees. We're going to kick off this morning with a panel discussion, as I mentioned earlier this morning. And we have our panelists live with us at the moment. And we're going to discuss protecting operational technologies and control systems against cyber attacks. Today, we are joined by Michael Wiegand, co-founder and chief growth officer of Shift5.
Good morning, James. Thank you for having me.
No worries, sir. Thanks for joining us. Alfredo Perez, principal owner of Perez Consulting, LLC.
Good morning.
Alfredo will be moderating today's panel. Todd Ellis, senior director with Nextlight Incorporated, has joined us.
Good morning.
And Bob Spadafora, senior executive officer for Rail Fleet Services with LA Metro.
Good morning.
Without further ado, I will hand this panel over to you, Mr. Perez.
Thank you, James. Good morning to everybody, and I appreciate your time today. I'm excited about the panel because it's going to provide you a different perspective from the industry, from the vendor technology side to the experienced project manager and design person to actually an end user who has to deal with this problem on a daily basis. So the three areas we're going to cover today is convergence of cyber and OT. The second one will be operational analytics, and the third one will be real-time dashboards. So let's start with a poll. We'd like to do an anonymous poll, and to find the poll, go to the events section on your right tab, and then you'll see polls. And the poll will be a simple yes or no. Have you previously had internal discussions on cyber threats to rolling stock assets? Please respond. We're just getting an understanding of how many people really are dealing with this problem today and have an understanding of it. Secondly, we're going to provide and define what we're talking about in terms of OT. So James, if you could bring up the first graphic, we'd appreciate that. And Michael Wiegand from Shift5 is going to define what we're talking about OT and some of the issues that we're going to cover in today's presentation.
Bear with me, Alfredo. Bear with me for a second, guys. My sharing isn't working for my slides. Is there anybody else that has slides open? Okay. It worked 5 minutes ago. Bear with me, team.
Well, Alfredo, while James works to bring that graphic up, let's go ahead and just talk about operational technology as opposed to information technology. So, most of the cyber attacks that we see today against, private and public infrastructure are predominantly focused on the IT components, right? Computers, cell phones, servers, the traditional networks. Talking operational technology today, which is the focus of this panel, we want to step away from that world and kind of step into the rail yard, step onto the wayside, if you will. When it comes to rail infrastructure, the operational technology is really all of the embedded computers, the LRUs that comprise all of the automation under the skin of locomotives, of various types of rolling stock, whether they be powered cars, you name it. It's incredible today to consider the degree to which we have automated and added smarts to all of our technology that now helps move people and freight all across the planet. When we look at diesel electric locomotives in particular, today, we see that there are multiple subsystems at play to make them go. There's going to be a prime mover, a very large diesel engine, which is going to be entirely electronically controlled via an engine control unit, an ECU. There will be a head-end power generator set creating electricity for the rest of the passenger cars in the consist, also entirely controlled by ECU. And then, of course, there is, there's the big one, the main train computer, the TCU, the train control unit. These have been around for more than 15 years, but generally they are a microprocessor-based hardware solution that has firmware or software under the hood and is interpreting commands from the operator or the engineer via the human-machine interface and the various brake handles and acceleration handles, the throttle lever. It's interpreting all of that, all of those inputs from the operator, along with real-time sensor input from across the locomotive, in order to determine how much energy, for example, goes to traction motors, in order to monitor and control for wheel slip events, etc. Of course, with the rollout of positive train control, we have further automation in order to report the location of the train and make sure that it is not accelerating, into an immovable or other obstacle on the road. So operational technology in the context of my profession really constitutes all of those embedded electronics and computers that come together to make the thing do the thing. Another way of considering it is all of the computers that interact with the physical world. This cyber physical boundary really is blurred because their purpose is to control mechanical outcomes.
Thank you, Mike. Bob, is that in line with your view of OT? And what concerns do you have with cyber threats, especially with the Olympics coming down your way in 2028?
Yeah, well, it's definitely in line with our thinking. We are just scared to death of the whole system just shutting down or different lines being shut down at any one point. It could also sponsor terrorist activities when these things are going on. So to be aware and to mitigate these attacks is something we have to do starting now. I mean, 2028 is a ways away, but it takes a little bit of time to implement these systems. So we're definitely concerned, and we're looking to put something in place that can handle any of these threats.
Yeah.
Alfredo, may I interject for just a moment? I'm sorry, gentlemen. My sharing options here are not working. You will need to share the slides, Alfredo, if you can, please.
Yeah, no worries. We'll work through that. Thank you, James.
All righty.
Thank you, Bob. Todd, what's been your past experiences? Because you have some incredible stories of your work in rail, and what threats do you see on the rolling stock side?
Well, it's really quite amazing, Alfredo, that we've been involved in positive train control systems in some major Northeast Corridor areas, specifically Boston, New York, and specifically Philadelphia, where we're located. And we understand PTC, we understand the I don't want to say downfalls, but some things that need to be protected better. And a lot of that translates directly over to CBTC. It's really kind of amazing, some things that have happened in the past. Case in point, we had a transmitter in one particular city, which will be not disclosed this morning, that we were testing, and it was at a wayside location. We were putting a high rail truck on the rail to go basically verify that we had coverage where we needed it. And it wasn't turned on. It was snowy. We had to send somebody out to turn it on. And one of my guys turned around and said, hold on just a minute, walked in to a bungalow with a laptop and a Cat 6 connector, network connector, okay, plugged in to a switch that was in the bungalow, and came out 3 minutes later and said, transmitter's on. I said, how did you do that? And he said, well, actually, I could see everything. I said, what do you mean everything? He said, I was in the network. I was in the train company's network and could see everything. They had ports that were not closed yet. And I said, yet? It's a little late. Well, the door had been opened. Anybody could have walked in. Our guy did. It was a little scary. Also, there was a rail alert that was sent out yesterday that we reviewed, talking about physical access issues that have happened on passenger rail, where people have actually just literally walked in and started manipulating locomotives. That's scary. If they can do that, how easy is it for them to access any communications port on that train, whether they're on Ethernet or any of the serial buses that you'll find on a train? What's the capability for them to slide in a USB stick or something like that and deposit malware? They have no idea. And a lot of these networks are so disparate. You might have network A, network B, and then Ethernet C. Who's monitoring all three? In a lot of cases, that's not being done. And that's one of the issues that Mike has really been pushing forward.
Do you predict, Todd, what's your prediction on standards, coming down the pike for, the OT side against cyber threats?
That's a great question. I heard a presentation yesterday here talking about NIST and ARIMA and stuff like that, and the test track and so forth. There needs to really be a call for that from the rail agencies. And I think some of them are just beginning to understand the depth of the problem. There's one particular transit agency, again, I will not name names. We're sitting in their office and we asked them, have you seen any problems? And they said, oh, we don't have any problems. We're air gapped. And I said, wait a minute, time out. You have a lot of fiber that you're using. And they said, well, yeah. I said, well, has it ever gone down for like 10 minutes? And you'd sent somebody out in the field to check on it, and they came back, no problem found. And the three individuals we were talking with, one could be on this presentation now. It wasn't Bob. I'm talking about somebody from the audience. They started looking at each other, and you could see the sweat starting to form on their foreheads. How did you know? And I said, you've been penetrated. And they said, but we've had Homeland Security come out and look at all of our stuff because there's some big events that happened out our way and people had to take the train and they were afraid. I said, it's not a matter of if they've penetrated, it's are you able to protect yourself from the penetration? And that is a different mindset that, frankly, rail agencies need to really start thinking about. And that's some of the stuff that we look at, from our deep experience in rail. What are some of the areas that people miss? What are they not thinking about? For example, did you know that your fiber was penetrated? We figured that out and we didn't even have to look. Did you realize that you left the door open to the passenger train and somebody waltzed in, sat down in the engineer's seat? And oh, by the way, there was a serial port there. Did you know that? I didn't think about that. See, these are the problems that we've really got to examine more closely. And they're simple. And unfortunately, that's where the opposition comes in. They look for the simple.
Yeah, I know. Good point. Mike, with your previous experience as a military cyber expert, what do you see the military doing to protect their vehicle assets? And how do you think that's going to translate over to the rail rolling stock?
Yeah, so Alfredo, when you look at it from the defense perspective, most weapon systems, right? Think major military vehicles, aircraft, ships. They are complex systems of systems, and they rely on lots of automation, lots of embedded compute in order to shoot, move, and communicate. So the military is very concerned about this, and I'm really proud to say that the U.S. defense industry is far and away, I think, a leader in OT cybersecurity, both in appreciating and studying and continually testing and understanding where their risk posture is, and also in making investments so that they can deploy intrusion detection and intrusion prevention technologies to both monitor what's going on the internal serial networks, those real-time control networks inside, the nervous systems of those weapon systems, but also working with their entire supplier base to roll out technologies to kind of control all of the various components that get mixed in to bake the cake, so to say. My expectations are that the transportation world will eventually adopt a set of standards that require really basic cybersecurity requirements, like we've kind of seen be adopted across the IT world. I think that in the future, we'll see that LRUs that you can purchase from OEMs will have data encrypted at rest. We'll have cryptographic validation of software and firmware updates. We'll have trusted embedded modules so that they can validate the efficacy and security of the operating systems and the control systems that are booted up. These are really techniques and capabilities that we take for granted inside our cell phones, and have kind of been standard in the IT industry now for over a decade. I think that we're going to see those best practices permeate into the OT world and the controls world that transportation is underpinned by.
Mike, do you see the locomotive manufacturers basically guaranteeing that they're, doing cyber protection for their firmware? Because that seems to be some of the areas of concern right now for the rail agencies.
So certainly, the OEMs have a leadership role and an opportunity. But, looking at other industries that have been dealing with this problem now for, 15, 20 plus years, the OEMs are not going to be the ones that are held liable or are left holding the risk at the end of the day. It's going to be the operators. Additionally, when you have a product company, that bends metal and builds a machine and then puts it out in the world, they don't have the economic incentive to continue to update it and provide that life cycle maintenance and support and continue to defend and research and really enhance its capabilities as the cyber threats evolve over time. That sounds like a services play, and just the economics of the transportation industry haven't been set up to support that kind of incentive yet for OEMs. So I think that what we'll see is that over time they'll start to roll out new features that will provide a measure of security out of the gate, but that it will always be up to the operators, up to the users, up to the buyers to secure their implementation and instance of their capital their capital assets. Ultimately, the OEM doesn't really have the responsibility, nor are they in a position to secure how equipment's actually deployed and used in the real world.
Bob, any input from you on the standards and what you see coming down the pike?
Yeah, definitely. What I see is having real-time advanced warning of anything that's going on in the systems is something that's very critical to operations and maintenance. We have to know. We're good at reacting to things, but it's better if we know ahead of time. We can be way in advance of what we normally do. So we definitely need to look that way. The other thing is we need to have what I call a cyber way of thinking now with everything that's going on in the world. The industry, especially in the U.S., the rail industry is always behind things that are going on in Europe. But I think if we start at the design criteria and embed the specifications of what we're looking for as a cyber element would be very helpful for the industry moving forward.
So we're going to pivot to the operational analytics, which is in line with what you just talked about, Bob. Preventive maintenance and doing things before they break down in a proactive way. What is LM Metro doing from an operational analytics point of view to have that preventive maintenance, especially across all the different diverse manufacturers you guys have at LM Metro?
Right. Yeah. Well, one of the things we're within the next 6 months, we have a project that's going to be put on the street, and basically what we're looking for is a lot of different things. But for me as the maintenance guy, we're looking to get them health monitoring of everything on the train in real time. If we're able to do that, we can get our parts in line. We get our workforce working within sync of each other. It would be very time management of all that would be extraordinarily beneficial to the operation. The other thing too is what we're looking to do here is not only the real time, but to see what the operator sees. Because a lot of times we have technicians and people that are out on the line, but when they get out there, they don't normally. By the time they're constantly being asked, get the car moving. But if we had an advanced system that we at a help desk that we can get that information directly from the train and we can feed it to the tech who's en route, that gives the guy more of a chance of finding the problem quicker, getting the train moved out of the way, and advance the system much better than what it is today. So we're looking to move forward with that. In addition, we think that's going to help drastically the time to get the car out of service drastically reduce that time. And if we could do that, that helps the operation, and it kind of makes it seamless to the passengers. They won't even know what's going on because it'd be such a quick thing, as opposed to finding out everything as it goes.
Which is critical to get your ridership back to the levels that you were in a pre.
Yeah, we can do anything we can do to bring our people back. You know, we will do it, and that's part of this.
Todd, you've been a big proponent of, you know, what you call conditions-based maintenance. You've spoken about it, you know, for years now. What do you see the impact, you know, of operational analytics to the rolling stock in terms of condition-based maintenance, preventive maintenance, whatever you want to call it? But you've been a big proponent. What's your assessment of that?
It's huge, and it's really kind of funny. All I have to really do is get in my car. I drive a BMW. In 2009, in fact, we talk about this in a paper we're writing for the GRC conference. In 2009, the 7 Series came out with these initial ways of understanding what's going wrong with the car. Now, my 2018 I drive today told me, oh, your brakes in the front have these many miles left, and the brakes on the other half also have to be maintained, but not so quickly. But you might want to do it at the same time, and the brake fluid is due in a little while. So you might want to go and get this checked out. If it gets to a certain point that there is an actual failure, it will actually automatically call BMW and tell them, hey, this guy's got a problem. We need to send somebody out right away. That's all covered under a simple system. Now, it's not really simple. You have to have the ability to monitor all these disparate networks. Now, move that to a train. Wow. What are the first 2 things that one of our clients have told us that they want to monitor all the time? Well, HVAC and toilets. You don't want to find out at 10 o'clock in the morning when the reports normally go out that at 5:30 when that car left for its first run in the morning, that first of all, there was no heat or there was no air conditioning, and the toilets had not been maintained. Therefore, you got a real problem. You got a 40-minute commute from the far end of that particular line, and you got people that are unhappy when they get off the train, and they voice that unhappiness not only to the conductor but to everybody else having to do with the train. So that's really a significant problem. So all the other things that come in too are, for example, fans on locomotives that don't talk to any other system aboard the train, but there's an hour meter. Well, who gets on the train and monitors the hour meter by plugging into it? Nobody. It's very similar to building management systems where you understand that the HVAC system needs a new filter. Why? Well, airflow's down. Well, what's monitoring that? See, all this stuff exists on a train today. It's just disparate. There are some systems that pull some of this information together, but not all of the systems. So how are you expecting to have a well-maintained train that is going to hit all of your time constraints that you have? The one worst case scenario I ever saw was a test train belonging to a passenger rail company. They had a frozen axle problem that we didn't know about until we got 300 feet forward. We ended up getting a half a mile out. It took a 2-hour period to get the train to that half-mile point and then back when we realized this wasn't going to fix itself. We had no other way to diagnose, monitor, or predict that this problem was going to happen. So you got 20 people on a test train testing something that's a real critical particular need, 2 o'clock in the morning, and everybody's unhappy. So having the ability to monitor, understand, and maintain rolling stock without anybody on board is extremely important.
And would you say, Todd, that it's even more critical today because of the tight budgets, the rail?
Very tight. You know, case in point with those fans, right? So we know of one rail agency that said, well, you know, we're going to change it out every 12 months because generally speaking, it's about that many hours. Well, maybe the bearings on that fan are really good for 14 months. So now you just took 2 months of longevity from that product that was aboard that locomotive that you really didn't need to waste. It's like taking tires off of a car that only have half tread. There's really no need to change the tires yet. You're not at that point unless you want to. But when you get to budgeting and on board a train with passenger rail systems that are really fighting budget problems right now, especially with COVID, you're far better spending just a little bit of money to get those predictive analyses. Yeah, we're starting to draw a little bit more current on that fan. Therefore, it's time. Let's schedule and we can get that off the line and get that fixed. And we got 14 months out of it, which is a win for us because normally we would have done it in 12. That's, nickel and dime here adds up to a lot of money when you're running a rail organization.
Right. No, I agree. And Mike, from a technology vendor side, as Todd said, the budgets are very tight, and Bob's aware of that as well. What are the technology vendors trying to do in terms of providing the cyber protection, but also giving them the cost saving, which is important?
Well, Alfredo, in order to, provide comprehensive cybersecurity resiliency and monitoring on board rolling stock today, you have to be able to first be able to tap into, acquire, and continuously monitor all of the data on the onboard communications networks, whether those are TCN, some type of industrial Ethernet, 1553 bus, CAN, J1939, et cetera. Your intrusion detection systems need to be able to continuously capture, monitor, and understand what good looks like so that they can pick out what potential threats are. But identifying threats and then distinguishing them from maintenance anomalies is not a trivial problem. And so if you're doing the data acquisition for cybersecurity, and you're doing it better than existing data acquisition solutions that might come siloed from one vendor, focusing on just one subsystem, et cetera, then you have an incredible platform to provide really rich data acquisition capabilities to the railroads. And with that, there's an enormous amount of enterprise value that can be uncovered. So, I think the sophisticated freight railroads have been doing a wonderful job using, the locomotive interface gateways and other solutions, sold by vendors to capture really high value data. But what we have found working with the defense industry and some of our initial rail customers is that comprehensive data acquisition was just not being done. And what I mean by that is that we weren't plugging into and capturing 100% of the data frames and data packets across all of the systems that are communicating over networks on a particular piece of rolling stock, whether that's a powered car or a locomotive. You have to do that for cybersecurity's sake, but then to take that data, be able to label it, right, do the data wrangling, put it into a data store, and then shovel it out, to existing SIEM, enterprise asset management tools, whatever the case may be, and then overlay, an analytic training capability or expose, the railroad to this data so that they can bring in their own preferred vendors to do that data science. There's an incredible value there. I guess what I'm saying is that there's a dual value proposition that COVID-19 has forced technology companies to acknowledge, and that is that cybersecurity and data acquisition are done best together. And when you combine them, the ROI, the return on investment to the railroad, is actually net positive. You can increase security, safety, and at the same time save cost of money by doing better data acquisition than employing that operationally and through maintenance. And I think that that's an industry innovation right there. I think that there's a lot more that we're going to see come out. I hope that more technology companies pick up on that and recognize that when you democratize this data and you make it available, to the operator, to the railroad, the ways that they can employ it and use it across their business, across the enterprise is really striking. And I'm talking about taking the data beyond just ops and maintenance. This data has incredible value for enterprise programming, has incredible value for emissions control, monitoring, testing, et cetera. I mean, this goes, I think, beyond just predictive maintenance and, predictive fault identification. So that's really our big takeaway from from COVID-19. There's a silver lining in everything, and that's been the big innovation that we've been trying to champion across the industry.
Yeah, and Bob, that's a big issue that Mike's talking about, and probably part of what's driving LA Metro to do what you're doing in terms of future acquisitions. What do you see as some of the cost savings from the conditions-based maintenance or predictive maintenance in your world?
Right. I think Michael hit a lot of things, the nail on the head on a lot of things there. One of the things we always want to do in maintenance is enhance our maintenance planning. Planning is a key thing. Scheduling. I rather do scheduled maintenance than breakdown maintenance. You know, anybody that's been in this industry as long as I have, you want to be ahead of the game. You want to have the information is power. If we get this information ahead of time, we can do a lot, not only at that moment, but we can do things future when it comes to retrofits, when it comes to modifications, when it comes to new specs. We have this new data now that we didn't have before. We don't have to rely solely on the, for example, when we write a spec, a consultant basically picks a spec that is similar to what the equipment we're using, but they don't have the real data of the equipment that we are using. So that's where we come in. That's where the end user comes in. If we can get that information into the spec, now we have a much more powerful document that can give us something at the end of the day to give us better reliability and easier to maintain. The other thing, it's obviously going to be cost effective, which we're all looking for, especially with COVID and everything else that's going on. Any money we can save is a good thing. It also is going to enhance our response time. We're going to be able to get things done a lot quicker. A lot of what this COVID has done is it's taken a lot of our people out of commission. So the fact that we're able to survive is one thing, but if we're able to cut down on the response, cut down on some of the things that we normally would do, that helps get the operation, move the operation forward. And lastly, I would say one of the things it's going to do is our customers' operations. So by us having a more efficient operation, we can help our customer better. And that's what we want to do. Not only our customers that ride the train, but my customer whose operations, I get them the trains on time, I get them the number of trains they need for rollout every day. It makes life a lot easier down
Yeah, I mean, your work really can't be done over Zoom too much. So
yeah, exactly.
So we're going to pivot to the third and last segment here, which is the real-time dynamic dashboards. And I've been a big proponent of that over the years, not only for the OT side, but the video surveillance side, all different departments with transit agencies. And part of that is because I don't understand how you can run an operation, no matter what the responsibilities are, without having real-time information, especially with all the issues that come up with transit day to day. And so, whether it's the location of the train, whether it's some of the components that are, breaking down, what are the trends over time that we're seeing on the brakes for this specific locomotive manufacturer, and so on and so on. Bob, what are some of the key data points for your department that you look at and would want in a real-time dashboard?
Right.
You're not getting it right now, right? Is that?
No, the only thing I get is on the cell phone. What I get on a cell phone is an alert that tells me something happened, and I get this nice young lady who's a cyber person that tells me exactly what happened, but it's not a real-time thing. Usually I get that probably 10 minutes after the event had already happened. Sometimes my guys are already out there doing the work, and I don't find out until it's already done. So having a dashboard, a real-time dashboard, gives us loads of flexibility and better reaction. We can get resources to where they need to go a lot quicker. The other thing it does too is if I can put different things on a dashboard that I may need. Like, for example, car history. Let's say I got a car that's out there that's had a problem. Maybe it's had a problem in the past. That comes up on the dashboard to let me know that, hey, that gives us the chance, rather than have to respin the wheel every time when we get on this train, to maybe get an advanced attack to get the problem solved. And we don't have any of that right now. Even the system, defining the system what system failed. For example, we get a report. I get a report. It says propulsion failure. What does that mean? The train's not moving? Is there a door open? You know what I mean? Does the operator press the proceed button correctly? There's a whole bunch of things that can stop a train from moving. But if we don't have the identified system, what's the problem? Door, brake, whatever, it makes it very difficult for the tech to figure out what's going on. So having a dashboard and be able to pick and correlate different things, similar things that happen for different particular system failures will help us big time. And especially if we put it in the help desk. Now we have, guys that know what they're talking about, talking to the guys that are in the field that know how to fix the train. It's a win-win. No question.
And isn't it the other part that I see, that even if some people have reports, the reports get sent to everybody, and half the people don't know what the report means to them. And so one of the things that I've been a big proponent of and wanted to get your input on is customized dashboards. So your responsibilities might be different from the engineers that deal with just one of the locomotives as opposed to all of them.
Yes, exactly. We'll have specifics that we're looking for. At the same time, we'll be able to take care of our bosses and what they need from the data and what they need from an incident. But again, to customize it and to get it to the way we like it is the key. And I think if we can get that, this industry will go leaps and bounds ahead of where it is today.
And Todd, what's your sense in terms of addressing the dealing with the rail agencies? How are they dealing with it based on what you've seen so far in addressing this issue?
Well, it depends on which one and how big they are, because they're very closely linked, whether they have something already and then how is it managed because of the size of the agency. So case in point, we have one particular client that said, yeah, we have this particular system from the rail manufacturer. It works kind of well, doesn't cover everything, but it covers the major stuff. Well, it sends out a report at like 10 o'clock in the morning. And as I'd mentioned before, the trains actually start running at 5:30. So now you have this 4 to 5 hour delay from knowing when you could have had a failure to when you get a notification. Then, as was mentioned by Bob, you have this kind of a, hey, something happened, notice, but you don't know what. So what they kind of desire in a second generation or even third is, okay, here's exactly what broke because we're able to sense that. Here is what kind of worker needs to get that information, and it needs to be routed to the guy that's closest to the train. So if you have a 200-mile, like this one particular, actually it's more than that, but we'll call it 200 miles in this particular line, when he gets to the end of the line, that might be one particular maintenance depot as opposed to at the other end of the line. So why would you send it to the wrong guy? You need to send it to the right guy. And that not only saves time, it saves manpower, it schedules the problem unless it's extremely urgent. We know about locomotives that have stopped on a main line and caused a huge delay because now you got to get a rescue locomotive out there to fix it. And then the other point is that you have this communications interface to talk to get this real-time information back to the train master or whomever, operations, however you want to manage that. And oh, by the way, while you have that, and you're also monitoring all the other systems aboard the train, that could also be a secondary communications link for your positive train control, CBTC, all these other safety oriented real-time communication methods because you have real-time monitoring on the train. So, okay, you have a dedicated PTC circuit. Great, wonderful. You have 220 radios. They work wonderfully well. It's reliable. What happens when it goes down? This was something that we discussed with a very large railroad here in the U.S. early on in their PTC project. What happens when the train, frankly, is too close and is overloaded and can't stop? What's going to happen? And I don't want to talk about that any further, but if we knew immediately that there was some kind of a problem with the wayside, we could have rerouted through the secondary communication system and prevented any kind of those problems from happening. That doesn't happen right now. And that's a huge benefit that by having this system on board a train, doing all of these different things we talked about, that alone could be a lifesaver.
Do you see requirements for that coming soon where all the agencies are going to require that?
We've been talking about it very, very quietly for some very obvious reasons. We will continue to do that. We invite railroads to reach out to us. We prefer not to, talk too much further about that in any depth.
And Mike, finally, from your perspective, from the vendor side, what do you see happening on the dashboards? I mean, it's becoming more and more important for the real-time information. What's your sense of where the market is today from the technology side?
So I think that the market today, data visualization, the way that the information, is conveyed to managers, has been executed in a very siloed way on an OEM, specific basis. And I think that the railroads are underserved because of that. I think that many of the solutions that exist out there, to answer Bob's call, right? They're inflexible. Often they're expensive, and they're only ingesting data from a particular silo worth of data, typically associated with that OEM's, kind of span of control, or the products that are associated with them. And that doesn't answer, I think, the industry's call, which is that they need to be able to see and monitor in real time, have insights, know where to put their attention before failure is, but across all of their subsystems. So there needs to be a much higher level of integration than we've seen in the rail industry. I personally think that rail technology has been lagging other industries in terms of the integration potential, and in terms of the way and means with which information, knowledge is communicated to decision makers, so that they can appropriately and take timely action to increase over the road performance, to decrease downtime, to address the metrics that they're held accountable for. So Alfredo, I think that there's a lot of work to be done, I think, to summarize.
Yeah, it's getting, and it's with the budgets being tight, you have to do it better, faster, cheaper. That's it for us on the panel. Our time is up. I wanted to thank everybody on the panel for their time, especially Bob for being in LA time and actually coming in at 3 o'clock in the morning for this panel. So Bob, thank you very much. And James, thank you. Are there any questions that the panel can answer?
There's nothing in the chat at the moment, gentlemen. Monitoring the polls for us, so that's something you can check out when you're off this session. But no, there's no present questions. Thank you very much for participating, all of you, and thank you for helping to put this together, Alfredo.
Thank you, James. Thank you.
Thank you. Take care.
Okay.
Guys.
Good morning, everybody.
Okay, Mike, if you can leave the session, then we'll go ahead and get started. Thanks. Thank you. Okay, great session. We're going to come back here with Sash Rigby from Modux in just a moment, and talk a little bit about remote operational technology and the vulnerabilities of breaking and entering into OT. See you in just a moment. We'll be back at 2:50, actually, Greenwich Mean Time, or if you are in the Eastern United States, as you should be, 9:50. We'll be right with you.